notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018 to 2027. Schedule of videos in September of this year, that's September 2024. I am hoping that I will have all 32 videos published from section 1, number theory and computation. And then next month, October, the 15 or so videos from section 2, consumer arithmetic, and so on. Sets by November, measurement in December, statistics January 2025, algebra February 2025, and March relations, functions, and graphs, April geometry and trigonometry, and then May 2025, by mid-May, vectors and matrices. And that would cover all 9 sections of the syllabus. Just a reminder, section 1 is subdivided into 32 videos, all of which will be made available on YouTube in their entirety, the complete videos. This section forms the foundation on which the rest of the syllabus is based. How well you can handle this section will predict how well you will be able to do with the rest of the syllabus. And these 32 videos from section 1, they cover the math schoolwork up to the end of Form 3, with Forms 1, 2, and 3 work. Right now, we are here, LCM and HCF, and we still have to go up to video 32 in this section. We are at objective 6 in section 1 that says compute the HCF or LCM, read that as and, of 2 or more positive integers, 2 or more positive integers. And then it goes on to explain highest common factors and lowest common multiples. And this that you see up here is a print screen from the syllabus. Now, this will only require 1 video. As you already know part of this objective, the LCM part, from when we were adding and subtracting fractions. So let's deal with the LCM first, since we already did this for addition and subtraction of fractions in videos 1.3.3a and b, 2 videos. And we need LCM to compare fractions by making them equivalent fractions with the same denominator. So we have 2 uses of LCM. As a matter of fact, that addition and subtraction is basically the same use of equivalent fractions. So objective 6, we are on LCM. Suppose you need to find the LCM of 4, 5, and 6. Now recall in the last video, 1-5, we talked about finding factors and multiples. This is video 1-6. So lowest multiples of 4 are 4, 8, 12, and so on. The lowest multiples of 5 are 5, 10, 15, and so on. And the lowest multiples of 6 are 6, 12, 18, 24, 30, and so on. We go up to 72. Now, if you look at these numbers, these multiples, which one is the lowest and common in all three lists? Well, if you pick 36, you will notice 36 is not in this list while it is in this list, so it is not common to all three. If you pick 44, 44 is in that list, it's not here and it's not here. You go right up and we come to 60, and you will find that 60 is in that list. It is a multiple of 4. 60 is in this list. It is a multiple of 5. And 60 is in this list. It is a multiple of. So the lowest multiple that is common for those three numbers, 4, 5, and 6, is 60. The LCM of denominators of fractions are required in order to add or subtract fractions or to compare them. So yes, is there an easier way to define LCM? Yes. And if you recall what happened in video 1.3.3a, and we will review some of that right now. Now for the easier way to find LCM of some numbers, let's say these are the denominators of some fractions. So you set those numbers like this, and then you start dividing by the lowest prime number if it can divide anything in that row. And in this case, it can. So you start dividing by 2. 2 into 4 is 2. Bring that down. 2 into 5 can't go. Bring that down. 2 into 6, 3. Can 2 divide anything in this row? Yes. 2 can divide that 2, and you get 1 here. 2 can't divide that 5 without a remainder, so you bring it down. Nor that 3. So we are finished with 2. Next higher prime number is 3. Can 3 divide anything in this row? Yes. So once we get this 1, we ignore it. 3 can't divide 5, so we bring down the 5. 3 into 3 is 1. So right now we will ignore that column and this column because their factors are already over here. So we try 5 and we get 1. So what you have here are factors of 4, 5, and 6. Now once you get this 1, you ignore what is on this right hand side and we will just concentrate on these divisors. We multiply all these divisors and we get 60. So the LCM for 4, 5, and 6 is 60. Let's look at another example that we did previously. Find the LCM of 4, 5, and 8. So you set up the numbers like that. Can we divide anything by 2 here? Yes. So we try 2. 2 into 4, 2. 2 into 5, can't go without a remainder. Bring it down. 2 into 8, 4. Can we try 2 again? Yes. 2 into 2, 1. 2 into 5, bring down the 5. 2 into 4, 2. Can we try 2 again? Yes. Remember, we will ignore that 1 once we reach that. 2 into 5, bring it down. 2 into 2, 1. Ignore that column. Ignore this column. So now all we have here is 5. So we will try 5 into 5, 1. So now you could ignore that column and we will concentrate on these divisors. Multiply all the divisors. So you multiply 2 by 2 by 2 by 5 and you get 40. So the LCM of 4, 5, and 8 is 40. It's the lowest common multiple, meaning it's the lowest number that 4 can go into, 5 can go into, and 8 can go into without a remainder. Lowest common multiple. Let's try one more that we also did before. 5, 6, and 8. So this is just a review. Set it up like you did before. We will begin with the lowest prime number if it can divide anything here, and it can. So we divide by 2. 2 into 5, bring down the 5. 2 into 6, 3. 2 into 8, 4. Can we try 2 again? Yes. 2 into 5, can't go, bring it down. 2 into 3, can't go, bring it down. 2 into 4, 2. Can we try 2 again? Yes. 2 into 5, bring that down. 2 into 3, bring that down. 2 into 2, 1. So we will ignore that column. Let's concentrate on this 5 and 3. The next higher prime number is 3. So we try 3. 3 into 5, bring down the 5. 3 into 3, 1. Ignore that column. And now we try 5 finally, and we get 1. Ignore that. Let's concentrate on these divisors on the left. Multiply all the divisors. We get 2 times 2 times 2 times 3 times 5, and we get 120. That is the LCM of 5, 6, and 8. So we already saw one use of LCM before to add and subtract fraction. We are just going to use one example in this video. So if you have 4/5 and 2/3 and 1/6, and you want to subtract the 2/3 from the 4/5 and then add that to the 1/6, you set it down like this. We find the LCM of 5, 3, and 6. And by now you know you don't have to use 3 again because 3 can go into 6. So you just deal with the 5 and the 6, and we get 30. We draw a line down here, and we put the 30 below it. And then you say 5 into 30, you get 6. You then multiply that 4 by the 6, and you get 24. What you are doing is you are expressing 4/5 with a denominator of 30. So 4/5 is the same as 24 over 30. Bring down the minus sign. 2/3, 3 into 30 is 10. 10 times 2 will give you 20. So 2/3 is the same as 20 over 30. Notice we are taking these fractions to the same denominator. And then, of course, 6 into 35 ones 5. So at this point, 4/5 is equal to 24 over 30. 2/3 is equal to 20 over 30. And 1/6 is the same as 5 over 30. Now that you have the denominator the same, you can add and subtract the numerator. So 24 minus 20 is 4 plus 5 is 9 over 30. We can reduce that, and we get 3/10. So you have seen this use of LCM before. We are not going to go over that again. We will move on to HCF because this may actually be new to you. So we can compute LCM. Now we are going to deal with HCF. Let's deal with finding the HCF of 2 or more positive integers. As the name suggests, highest common factor is exactly that. What is the HCF of 20 and 30? Now recall from the last video, we were finding factors and multiples. Now we are dealing with factors. In LCM, we were dealing with multiples. Now we are dealing with factors. So the factors of 20 are all of these. Those are the factors of 20. These are numbers that can divide 20 without a remainder. The factors of 30 are these, 1, 3, 5, 6, and so on. These are all numbers equal to or lower than 30 that can divide 30 without a remainder. So we are dealing with the highest factor, not the lowest common multiple, but the highest factor. So we look at this 30, is 30 over here? No. We look at that 20, is 20 down here? No. We look at this 10, is 10 down here? Yes. So those multiples that are common to both 20 and 30 would be 10 and 10. So what do you do? You pick that, and that is it. It is the highest common factor. You don't have to do anything else with it. You just pick it. If you do it this way, HCF of 20 and 30 is 10. Let's look at another method, which may be a little faster. What are the prime factors of 20? 2, 2, and 5. We write them all down. What are the prime factors of 30? 2, 3, and 5. Now, in this case, we will multiply the factors that are common. So you notice that 2 there and that 5 there. We multiply the 2 by 5 and we get 10, which is the same answer we got when we did this the previous way, writing down all the factors, writing down a series of factors. In that case, we just pick the highest common factor. In this case, if we are dealing with prime factors, we will multiply the prime factors that are common to both numbers, and we get 10. So the HCF of 20 and 30 is 10. That's example 1. We did that 2 ways. Let's try another one. Example 2, what is the HCF of 15, 25, and 30? So we write the prime factors of 15 would be 3 and 5. The prime factors of 25 would be 5 and 5. And the prime factors of 30 would be 3 and 5. Now, do we have anything common here? Yes, we only have 5. We don't have anything else. Now, if we had something else, we will multiply that something else with a 5. But because we only have 5, that is it. We multiply the factors that are common. Well, we only have 5. So 5 is the only common factor. So the HCF of 15, 25, and 30 is 5. Let's try a third example. 20, 30, and 50. The prime factors of 20 are 2, 2, and 5. Remember, we'll write down each one. The prime factors of 30 are 2, 3, and 5. The prime factors of 50 are 2, 5, and 5. Now, do we have anything common in there? Well, sure, we have a 2 here, and we have a 5 here. So we will multiply those 2 factors that are common, and we get 2 times 5 would give us 10. So the HCF of 20, 30, and 50 is 10. That's example 3. Let's look at one more example. Let's find the HCF of 12, 20, and 32. The prime factors of 12 are 2, 2, and 3. The prime factors of 20 are 2, 2, and 5. And the prime factors of 32 are 2, 2, 2, 2, 2. Okay, do we have anything common to all 3 of those lists? Well, we have a 2 here, and we have another 2 here, and that's about it. So you multiply the factors that are common to all 3, and in this case, it is 2 times 2, which would give us 4. So the HCF of 12, 20, and 32 is 4. Let's look at another method to do this one. This was example 3. Some people may actually prefer this method than the 2 previous methods I just discussed. So you set it down as if though you are going to find LCM. You set down the 20, the 30, and the 50. And you go through the same procedure as if though you are going to find LCM. So we start with 2. 2 can divide that 20, we get 10. 2 can divide that 30, we get 15. 2 can divide that 50, we get 25. So can we try 2 again? Yes. 2 can divide the 10, we get 5. 2 can divide the 15, so we bring it down. 2 can divide the 25, so we bring it down. Okay, so we finish with 2. Let's try 3. Let's try 3. 3 into 5, bring it down. 3 into 15, 5. 3 to 25 can go bring it down. So what should we try now? The next higher prime number, which would be 5. So 5 into 5, 1. 5 into 5, 1. 5 into 25, 5. At this point, you don't need to continue. And I'll explain that in a moment. You just stop here. Once you get 1 in any one of these rows, you stop. The thing about it is, which number or numbers divide every number in a row? Let's look at that. Did this 2 divide every number in this row? Yes. So keep an eye on that too. Did this 2 divide every number in that row? No. Did this 3 divide every number in this row? No. Did this 5 divide every number in this row? Yes. So keep an eye on that 5. And remember, we were dealing with that too. So which number or numbers divide every number in a row? And the answer to that is 2 and 5. So you multiply those two. You multiply 2 and 5 and you get 10. So the HCF of 20, 30, and 50 is 10. Now, this is another method. Be careful with it because you may confuse it with LCM. Okay, so what use is HCF? Why do you need to know HCF? So we will use this third example as an example and another one. One use is to equally distribute 2 or more sets of items into their largest possible grouping. So let's look at an example. Let's assume that you have 20 ice cream, 30 chocolates, and 50 sweets. What is the highest number of children you can distribute these to so that each child gets the same amount of each item and they wouldn't fight saying that one gets more than me? So we know that the HCF of 20, 30, and 50 is 10. We did that before. So that would be 10 children, where each child gets 2 ice cream. You divide 20 by 10. Each child gets 3 chocolates. You divide 30 by 10. And each child gets 5 sweets. You divide 50 by 10. Now, this is one use. It's not a common use as we do for LCM, but it is used this way for HCF. That is one use. We will look at one more. We know that the HCF of 12, 20, and 30 is 4. We did that as example 4 when we were finding HCF. Now, another use of HCF is to divide unequal pieces of material so that there is no wastage. So here is the problem. A student wants to do an experiment with equal pieces of construction steel. At a construction site, he was given 3 discarded pieces. They do normally throw away some end pieces of steel. And the 3 pieces he got was 12 centimeters, 20 centimeters, and 32 centimeters. And he wants to cut them up into the maximum number of smaller pieces without any wastage. So the question is, what will be the length of each piece and how many such pieces will he get? Looks kind of difficult to begin with. Let's use HCF to solve this problem. Now we know the HCF of 12, 20, and 32 is 4. So right there is your answer. Each piece will be 4 centimeters long without any wastage. Total number of pieces would be 12 divided by 4. That's from this one. You get 3 pieces. And then 20 divided by 4. That's this one. 5 pieces. And then 32 divided by 4. That's this 32 piece. No wastage. You get 8 pieces. You add all of that up and you get 16 pieces of 4 centimeter length of steel. This may be new to you, unlike LCM. So you may have to look at it a couple of times to understand it. So in this objective, we were finding HCF and LCM of 2 or more positive integers. And that's it for this objective in section 1 for this video.